دلوقتي احب اقدم شابه متميزه اخرى. هي ابنتنا نادين مصطفى. نادين باحثه دكتوراه في قسم الهندسه الكيميائيه بجامعه امبيريال كوليدج في لندن. حصلت نادين على درجه الماجستير عن الوقود الحيوي بجامعه برمنغهام. تركز ابحاث الدكتوراه الخاصه بنادين على تكنولوجيا التقاط ثاني اكسيد الكربون من المصانع والتيارات المماثلة والهواء. تعمل نادين كمستشار متخصص حاليا في التقاط الكربون واستخدام وتخزينه والاستدامة واستراتيجيات النت زيرو. تشتمل مجالات عمل نادين على تطبيقات متخصصة في المجالات الصناعية لدعم التوافق البيئي من خلال الأبحاث العلمية في مجالات متنوعة، أبرزها الطيران، إنتاج الهيدروجين، وصناعة الأزياء. نادين مسؤولة البرامج والسياسات بتحالف الشركات والجهات المسؤولة عن تقليل الانبعاثات في المملكة المتحدة. نادين النهاردة هتكلمنا عن إمكانية تطبيق تكنولوجيا التقاط الكربون في المجالات الصناعية. إمكانية تطبيق تكنولوجيا التقاط الكربون في المجالات الصناعية المختلفة عند فهم التقنيات الفنية المتخصصة لكل مجال. اتفضلي يا نادين.
Thank you for the thorough introduction, Your Excellency. So yes, I did work in sustainability in a lot of industries such as fashion and aviation and high production. But today I'm going to speak to you about carbon capture and storage because that's where it started in terms of my sustainability career-ish. So carbon capture and storage is technology that revolves around capturing up to 90% of carbon dioxide emissions from point sources. So for instance, it could be from plants like fossil fuel plants, but it can also be from harder to abate sectors such as cement and stainless steel. There are currently 196 projects in the CCS facilities pipeline, according to the Global CCS Institute, and that's already a 44% growth in just 1 year from 2021. Carbon capture revolves around capturing the carbon dioxide, as you can see in the diagram on the right, and then compressing it and liquefying it, transporting it and storing it permanently. And in that sense, you end up removing the emissions permanently from the atmosphere. There are several technologies, as with any sustainability route of carbon capture. Chemical absorption, membranes, adsorption, and chemical looping and oxy-fuel combustion. But I'm going to talk to you about chemical absorption today. One, because that is what my PhD is about and what I work in, but also another fun fact, it is the most commercialized one out of all the technologies because we've been using it for 50 years or so, but in another industry. So we've been using it for natural gas sweetening, where we remove hydrogen sulfide, which is also an acidic gas, just like CO2, and well, in that case, it's toxic, but we removed it so we can get natural gas safely into our homes to use, for instance, in our stoves. Now, just a brief fundamental introduction. So amine absorption revolves around chemical absorption, which is a chemical reaction that revolves around molecules or atoms, so the gas, for instance, in this case, CO2, moving from the bulk gas and chemically reacting with the liquid and moving into the liquid bulk. In this case, it's a reversible reaction. So I don't know how much of us remember chemistry from high school, but reversible as in the products are not extremely stable, and so we could reform our reactants again. And that brings us to the large scale in an industry where it's a two-stage process. In the first stage, where the absorber is, so the yellow part, we capture the CO2, and then we end up doing the reverse reaction in the desorber, and then we get pure CO2 in the end. The reason we do this is because CO2's concentration in different plants and industries varies a lot. So it could be 400 parts per million from air, for instance. It could be around 10% for natural gas, and it could be up to 30% for cement. but we want pure CO2, and that's how we do that, and then we can liquefy, we'll compress it and store it. So my PhD. My PhD is extremely fundamental. So I'm in the chemical engineering department, and I was looking at interfaces. So you can see here the bottom left. Sorry, the bottom left picture. The bubbles are basically CO2 from our pilot plant in my department, and there's liquid flowing countercurrently to it, and that the CO2 reacts. Now, my research revolved around studying those fundamentals, including kinetics, mass transfer, thermodynamics, but also their interplay with each other, so that we can select improved solvent blends that we could use to capture the CO2 in a way that's more cost-effective and environmentally benign. The reason we do this, although I said we've used this for a while, is because although we've used it for a while, natural gas is economic. Like, we can sell natural gas, and so cleaning it up before, kind of like desalination or whatever, is fine because you're selling it. In this case, though, CO2 is currently, yes, sold sometimes for utilization, but mainly for carbon markets, which I'll speak about in a second. But I studied the fundamentals so that I can optimize it, and that has, and I've been doing that in industry now, in a company called Mission Zero Technologies, where I'm an R&D engineer. And the top right plant is in Oman, and it's actually one of the X Prize winners. And the bottom right plant is in the UK. And in that company, we're doing direct air capture, so we're capturing CO2 straight from the atmosphere. It's not point source, it's not from a factory, we're capturing it straight out, and then selling it as carbon credits to industry to offset their emissions. Which brings us to the way forward for industries, where negative emissions essentially is the result of any process where we're removing greenhouse gas from atmosphere, so it's reduced. The reason we need this, although we have renewables and nuclear and so on and so forth, even after doing all the abatement techniques, which are shown in gray in the graph on the right, we will still have residual emissions that we will need to remove to get to the 1.5 degree scenario or the 2 degree scenario, since the 1.5 is not looking promising. But even then, we're going to need to do greenhouse gas removal, especially for industries that are hard to abate, such as aviation, where we can't change the whole infrastructure within the next 5 to 10 years. Which brings me to carbon markets. We can capture the CO2 and then sell it in compliance or voluntary carbon markets. Compliance carbon markets revolve around carbon credits that are obliged by you through law, whereas voluntary carbon markets is where companies start offsetting their emissions because they realize the importance of contributing to the environment even without policies that force them to do that. And they do that by buying carbon credits from, for instance, planting trees, which I'm assuming a lot of people here are familiar with, but also direct air capture, which is what I talked about in the previous pilot plants, BECCS, which is bioenergy and carbon capture and storage, and several other technologies. Now, the most important thing about all of this is because there's, again, a plethora of technologies, we need agreed, robust standards that we can use to define what a carbon credit is. And right now I'm working with the Coalition of Negative Emissions in the UK to produce a report that highlights those recommendations, where it includes the role of companies that they should play into developing this market, and also how they should immediately build negative emissions to decarbonize strategies, and the importance of them buying robust, accredited carbon removals to ensure that, for instance, as simple as that the carbon credits you're buying are actually permanently stored. And again, actually, depending on, because of COP, it was announced yesterday that Egypt entered the voluntary carbon market, and so it'd be great to see a lot more. And it would be great to see CCS done in Egypt, but also things like direct air capture, where we can contribute to the voluntary carbon market. And also, selling those carbon credits could finance the loss and damage that's done from climate change. And from there, since I've spoken about industries, I'm going to pass on to Joe, who will speak about decarbonizing but from the consumer perspective. Thank you so much.
شكرا جزيلا يا نادين. قبل ما تمشي قولي لنا ايه المسج اللي عايزانا نروح بيها من البرزنتيشن بتاعتك.
I think the most important message is that, as you've seen, there's a lot of technologies that exist. One, there is no silver bullet technology. There is no one technology that's going to save us all from climate change. But two, it's extremely important and beneficial and helpful to study fundamentals so that we can optimize an industry. And I've realized that through my work from my PhD and then going and implementing it in industry.
هايله يا نادين. ميرسي.
Thank you so much.